Hey everyone, welcome to yet another Hasura live stream, the first of this month, December. Today's topic is going to be about security, how to secure GraphQL APIs with Hasura Cloud. Um, so we will touch base on general topics about securing GraphQL APIs. So even if you don't use Hasura, you will be able to like relate to some of the security aspects of going to a production server, right? So broadly, we'll start off with why security in GraphQL is different than REST APIs. And then we'll move forward with how Hasura helps you secure APIs with different authorization layers and the different pro features with Hasura Cloud, right? Um, so this is the blog post that I published today. Please do go check out. This is going to talk about how to secure APIs with Hasura Cloud. And this is what we're going to actually look at in this live stream. Um, so to get started, I think I'll just do like a quick demo of a GraphQL query for starters. Um, I have, let's say, a table called users. Um, then I go to GraphQL interface. I make a query. I get a response. So here, the difference with the GraphQL query and with the REST API is that you're making a query to a single endpoint, whereas in a REST API, you'll be making queries to multiple endpoints and different methods. In a GraphQL scenario, it's a post endpoint, and with the REST API, it could be a get method, it could be a post, it could be a put or a delete, right? So the HTTP verbs are different, and you can filter based on the URL, or you can filter based on the method, and you can filter based on the JSON object that you receive, right? In a REST API scenario. But when it comes to GraphQL, things are slightly different. You cannot filter based on the endpoint because there's only one endpoint. Um, and you cannot filter based on the method because it's just post method, right? So fundamentally, you're left with just working with a GraphQL document, which is basically what the query actually looks like. So this is the GraphQL document. This along with a GraphQL query variable. These are the a couple of information that will be available to the server, and you will have to perform some kind of authorization or authentication, and then let the GraphQL query respond, right? So that's fundamentally what is different from REST API, but there is more to REST APIs in terms of handling authentication. With GraphQL, it's no different. You can actually embed any authentication provider. You can use any vendor, and that shouldn't really affect how authentication is done using GraphQL, right? You can use, let's say, an external service like Auth0 or a Firebase, and then you can actually set up JWT and then forward headers, right? So authentication as such is not really too different when it comes to GraphQL. Uh, it will be very similar to how you would do with a similar REST API application. But with GraphQL, it's going to be very similar. The tricky bit is in the authorization bit, and we'll come back to that on why that will be a little tricky. So the first thing on why is it so different than a REST API, right? Is that you have a schema with GraphQL, and that is the underlying aspect of GraphQL, where any tool which knows your GraphQL endpoint will be able to introspect your GraphQL schema, and thereby they'll be able to predict what kind of queries you can make and what kind of mutations you can make to the server, right? So for example, the console that you're looking at right now has this GraphQL interface. where you can see some queries and mutations and subscriptions that are being built, like for example, asset, and I have a table called users. So all of this information is obtained because there is an introspection query that is being sent to the server to understand what the server is actually made of. And this lets all the tooling to work, all this Explorer tooling or any of the tooling that you see with GraphQL to work seamlessly. But this also opens up an attack vector where you're exposing your GraphQL schema to a stranger, to anybody in the internet, and then you'll be able to, and the attacker will be able to predict what the schema looks like, and then they'll be able to do a brute force attack, right? So the first thing is to prevent introspection of your GraphQL schema in a production server. So to do that, in your Hasura Cloud project, what you can do is you can go to allow list. So what allow list does is once you enable allow list, Hasura will just allow the configured list of operations to be executed and nothing else. So for example, if I go to the new operations tab here, I can see that I've made 3 queries to this project, and introspection query is one of them, right? So if I just explore this introspection query again, and I copy this operation string, I go back to GraphQL, and if I make this query, you can see that there is a schema response that the server gives back, right? So this is the response that is being used by all of the tooling to build uh, information about your schema, and this will expose your underlying GraphQL API, right? On what kind of fields and what kind of types are being used. So to prevent this, we can basically disable this introspection query as such. So going back to the allow list, I will actually enable allow list to just a user query, and then I'll say add to allow list. And once the allow list is enabled, okay, let me just refresh. I have to log in back again. Yeah, I'll repeat the user query. So I've added the allow list from the users query. So now introspection can be disabled once you enable allow list from this particular project, right? So just gonna refresh this, and if I go this. Yeah. So introspection queries are being made by the console continuously, and if you're actually looking to use the console, then you should allow the introspection query to be allowed in the list, and 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 since you're building the application with the limited set of features, you'll know that these are the fixed number of queries to be made to the server, and ideally the operations that you make on the GraphQL or to the GraphQL endpoint eventually will appear on the operations tab, and you can add them to the allow list, right? So let's say you are making 5 different queries, and you know for sure that they're the only queries that are being made to the server. You can actually add them to the allow list, and then Hasura will ensure that only those 5 queries will be allowed to be executed, right? So that's the first filtering that you can do to protect your GraphQL schema. And so basically disabling introspection depending on the requirement, and only enabling a certain set of queries to be made, right? So I'm just going to go to comments uh, to see if there are any questions and queries. Please drop in any queries as you see. I see Matthews. Hello, Matthews, and hello, another user, STC94. Great. So now coming back to our post. So so we've now looked at allow list to disable introspection queries. Now the next thing is what are the different ways to authenticate with Hasura? So Hasura gives you uh, different approaches to authenticate. You can use JWT, which is JSON Web Tokens, which you can configure with any vendor. You can create your own server with JWT tokens, and then Hasura will be able to parse your JSON Web Token, and it'll be able to validate your request, right? So that's one recommended method from from an authentication perspective. And you have something called webhooks that you can write. So, for example, uh, uh, if you have like an authentication system which deals with different auth systems, if you have different microservices dealing with different systems, and you have multiple authentication stuff to be done, typically in an enterprise scenario, you will have different systems talking to each other with different authentication mechanisms. You will have to do different approaches to each of those services, and you will have different vendors talking to each of them, right? So in a very complex scenario, you will probably want to use a webhook. So what a webhook does is, in if you've configured webhook in Hasura, basically Hasura, whenever you make a request to Hasura, Hasura basically pings your webhook, forwards all the headers and the session variables, and then sees that if your request is valid, and you can perform the custom logic in your webhook to say that the request is valid or not, right? So you get the headers from the client in the webhook, and for example, your webhook is in like a Node.js function. Um, then you can actually get the headers, and then you can validate if this particular request is a valid request or not. And if it's a valid request, then Hasura goes on to process the request, basically process the GraphQL query, and then converts into SQL, and then does the post processing. Right. So so JWT is one approach, and you have webhook if you have a very complex authentication system internally, right? So and also there's another one where you will probably want to have unauthenticated public access. So you have certain use cases where you want to expose certain queries without logging in to the API, without logging into your application. In that case, you can configure an unauthorized role. So if I go back to this environment variable, I can see that there is an unauthorized role environment variable. I can say be public, and I can add this particular role as an environment variable. So what this does is you can configure permissions for this role called public, and allow access for any tables and any columns that you want to be accessed without any form of authentication. So you don't need to pass in any headers to specifically access it. So you have to explicitly allow permissions for this particular role called public, or whatever role that you've configured, and then allow access to whatever tables and columns that you want, right? So this will be used in cases where you want to expose certain tables and certain APIs to be accessed by everyone without any form of authentication, right? So I mean, technically, you're actually exposing the API, you're not securing the API, but there are use cases where you would want to do this, and you can do this by configuring an unauthorized role, right? Cool. So so for all of these three use cases, the underlying fact is that you will start by adding an admin secret to your Hasura project. It's a no-brainer. You will have to secure your project with the admin secret first of all. Then you go on to add either a JWT authentication system or you add a webhook configuration, right? In this example, I have added a JWT secret to showcase how to use Auth0's uh, token to do some form of authorization going forward. Um, so for example, I have this authorization token. This was generated from Auth0. So if I decode this JWT, I should be able to look at the user ID values from Auth0 and the role value, which is the user. And you can see the full claim payload from Auth0, right? So this was set in the token. This was configured through a rule in Auth0, which lets you configure the JSON token. So here we're setting the user ID, we're setting the default role. These are all called session variables. So every time a user logs in through Auth0, you'll be able to set these values dynamically on every login, and you can set these values, and then the JSON Web Token, the token that gets generated, that will have an expiry time. Till which the token is valid, and using that token you'll be able to do requests and do authorization on top of that, right? So basically we've covered what are the different types of authentication with Hasura. You have JSON Web Tokens, you have webhooks, and you can also expose certain APIs through for public access through unauthorized role ENV, right? Cool. So the next one we would want to see is authorization, which is where we'll talk about permissions. So I have a fairly a simple example, which will involve something like a Google document file sharing mechanism use case. So I have a users table and I have a documents table and I have some owners and editors for each document, right? So if I go to documents table and if I go to relationships, I can see that each document has a list of owners and a list of editors. Right. So now the idea is that I would want to allow access for documents to be able to access by any owner and any editor. So if I go to select permission, so I have a role called user already, and I have a select permission. So I'm going to do a custom check for select. So here I would say uh, owners and the user ID has to equal to X as a user ID, the session variable, right? But we would want to actually do a combination check where the document can be accessed by either an owner or an editor, right? So what Hasura gives you is a Boolean operator. You can express Boolean expressions using and, or, and not. So in this case, I need the document to be accessed by either the owner or the editor. So I would use an or operator and followed by the conditions, which would be the owner user ID, which has to equal to the session variable accessor user ID. So this value is the one that you have set in the JSON Web Token payload. The Hasura claims will have this value set every time a login happens. And so this is the owner's user ID in the first condition. And next we have the editor's user ID. So I'm going to have user ID equals accessor user ID. So what we've done is we've used a Boolean condition to express a combination of two things. Either the user has to be an owner or the user has to be an editor, right? So if either of these condition matches, Hasura will let you select this table, the rows of this table, and the rows where these values match, right? You can also like specifically allow which columns to be accessed. This particular table has just one column, but technically, if there are multiple columns, you can specifically mention which columns to be accessed, right? So I'm going to click on Save Permissions. So so this is for select, and typically you will repeat this process for insert, update, and delete for this role called user. Ideally, in most cases, you would probably have a requirement of just using one role called a user, but that would probably suffice for most use cases. But in case you have like a hierarchical structure where you have a complex role sharing system, then you can have multiple roles where you can define different select permissions for different roles and for each operation individually, right? So this is one example of authorization where we've used a complex Boolean expression to express how to access um, a document, right? The other thing that we've done here is also that if you look at the owner's field, this is actually traversing through a relationship. So in fact, documents table has only one field called ID, and owners is actually a relationship to a different table called owners. So what we've done is we are traversing uh, uh, through to a different table from the documents table. We are traversing to owners, and then we are basically checking the user's ID, right? So we are actually looking at a relationship based authorization system where the data can actually reside in a different table than the one that you're trying to access, and the condition can be set in such a way that the related information also has a filter. So this is totally possible with Hasura. So you'll be able to configure permissions through relationships as well, right? Cool. Um, Right. So the next thing is you can also change. So in your client side, when you're making this request, so let's say I'm making this particular request with the authorization token. I'm going to remove the collaborator token, um, and I'm gonna make query for users ID and name. And I got back a response for my user. If I inspect this token, I have got the same ID here. So I'm going to go back to the users table to check if the permissions have been set for the select. And if you look at the row select permission, I have configured the ID column to be equal to the session variable called accessor user ID. So even if I have another value, let's say testing ID and another user. Here we have two users now. Now if I make the same query, I should be ideally getting only one user because my token actually is restricted to access only my own data. The role is user. If I go back to the token again, the GWT decoding, it will say that I am assigned the role user. So the select permission that we defined for the role user will be applied, and we are also like filtering for the accessor user ID, which is this auth0 ID string. So this string will be applied in the filter. So the rows that match this condition will be the ones that will be allowed in the response, right? And this is also generated in the SQL layer, and data is not filtered on the server side. Data is actually generated at the SQL layer by this filter. So this uh, think of this condition as a var clause that's actually been executed at the database level. So this query is actually pretty fast with the authorization system as well, right? Cool. So now coming back to the other stuff. So we have configured admin secret. We have gone through row level and column level permissions. Now we'll talk about API limits. So in any public facing app, you will have this requirement of uh, limiting the number of API calls being made to prevent abuse. Um, so like if you're a popular app, you will probably face a DDoS attack. The attack vector is that you have an endpoint where a series of requests are being made in a very short interval of time, and your server is not able to handle it, and getting down your database and your server API server at the same time. So that's a typical common attack vector that people use. So to prevent that, typically use some sort of rate limiting um, and some kind of defense mechanism for your API. Um, at Hasura, in Hasura Cloud, basically you have API limits that can be configured. So, for example, I can add an API limit for a particular role, and I can also limit the number of requests per minute. So let's say you want to limit the number of requests to a number like let's say 100. So and you also give a parameter like an IP address or a session variable. So let's go at one use case at a time. So let's say I have the use case of 10 requests per minute, which is pretty low, but just to understand this particular example. And I'm also going to have a parameter for IP address. So for each unique IP address, we can limit the number of requests to 10 per minute, which would mean that you can like prevent abuse based on IP addresses here. Or if you are very particular about which particular user or which particular role needs to have this limit, you can actually do a session variable limit as a parameter. So you can specify X as a user ID or X as a role or any custom X as a session variable to have a limit, right? So for example, I'm just going to select IP address for this particular example, and the maximum depth of an operation as well, right? So for depth, let's assume that you are making a query to fetch huge amount of data set, which traverses through different relationships. Now that will become like a huge join query in SQL, and that can take down a database if you're allowing n level of nesting without any form of authorization, right? So typically, you can configure a reasonable depth. Let's say, for example, in our particular query, here we're not making any nesting, but let's say I have a relationship query from documents. So I have documents here, I have ID, I should have the relationship owners, but since I don't have the permission, I'll enable the token. I will have owners, I'll have user ID, and I think there'll be user again, which will have rename. So if you look at this query, this has like 3 levels of depth, and you can keep going on. Like you can again do infinite level of depth by looping through the same set of relationships, right? So this will form a pretty heavy query after a point of time, and this will time out, right? So um, I've configured a depth limit of 1, which is what I've done previously. So I'm going to remove that limit to, let's say, 3, and I have a rate limit of 10 per minute for my IP address. So if I go back to this, I make this query. I obviously don't have any data, and I'm just going to keep hitting this to reach the limit. And I'm sure that I need to probably also make a normal query instead of an admin query. And obviously the rate limiting will kick in once I have made uh, yeah, once I've made more than 10 queries, I have now hit the rate limit. So the client will get this response of rate limit exceeded code. So this is purely based on the IP address filter. So in my API limit, I've just selected IP address. This could be a filter based on session variables, which could be accessor user ID or accessor role, or it could be any custom session variable, as I mentioned before, right? So this basically takes care of bulk of the issues that typically happen with abuse, where you can limit the number of requests. You can also limit the depth at which a GraphQL query can be made, and you can limit both of these through an IP address as well, right? So you can do a global IP address level limiting, and you can also do a session variable limiting for very user specific limit. So let's say you have thousands of users in your application, and you want each user to be able to make only 10 requests per minute. So this particular combination of API limit will let you do that. So this is pretty flexible. You can apply multiple conditions, and you can basically have filters for rate limiting, right? So this is the primary attack vector people use for GraphQL, where they make queries infinitely and try to DDoS, um, denial of service, and you can prevent that using this combination, right? Cool. So I would just look at some comments here. Um, Rahul asked a question, how do you scale it? I think I missed the timestamp here. It's probably 5 minutes earlier when this question is asked. So I would assume, yeah, I'd also go through Boris's question. Asura's access system is very nice. One important piece which is missing is the ability to limit access to certain fields. Other than that, it's very flexible. Ability to limit access to certain fields. So, so that is totally possible with Hasura, Boris. So I'm going to give you an example of that. Um, in fact, I showed you that example in the previous one. So, for example, users table in your select permission. You can specifically not allow access to the ID column, let's say. So this ID field is no more accessible by the user role. So if I start making a query, in fact, ID won't even autocomplete in your schema. So even if you make a query, it says field ID not found because your permission failed. I hope that was the question. Um, a missing ability to limit access to certain fields. You can totally filter based on fields, and you can also filter based on rows, which is the row level filter that we looked at, the Boolean condition that we looked at in documents table. So you can do both column and row level permissions, and they're pretty granular, right? So authorization is pretty flexible on that front. I hope that answers Boris's question. Cool. Um, right. So the next section that we want to cover for security is external APIs, like actions and remote schemas. So far we've covered authorization and authentication for your instant GraphQL API with Hasura. You obviously have custom business logic written using actions and remote schemas. So for example, you have an action which is a REST API, which is a post endpoint REST API, which is handling a particular response for this GraphQL type definition. Um, the problem is that this endpoint will also be accessible directly. Assuming this is my example.com/API/fetch user. Let's say this is the API endpoint. This API endpoint, which is a post request, this will be publicly accessible by anybody else. So anybody can actually directly make a post request and probably skip the authorization layer, right? So that's the common issue that you initially face while writing an action. To prevent that, what you can do is you can forward a header, which will be like a common secret that you share between Hasura and your custom action server. So, for example, you can just call that as um, action secret key. And this could come in from an environment variable. For example, this could be called as action secret key as well, and then you can set in the values in both your Hasura server as well as your custom action HTTP endpoint. So that's one way of looking at this, where you're actually sharing a common secret between two servers so that you're not able to actually hit this endpoint directly without any form of authentication. The other way is that that depends on your deployment method. If you're hosting Hasura yourself and you're hosting your action endpoint yourself, and if they are in the same cluster, you can technically namespace them and then just call them internally and do not expose this HTTP endpoint to the outside world. So this API server doesn't need to be exposed to the outside world, and that way Hasura will be able to directly access it through some port or through the direct namespace API. This is possible through a Kubernetes cluster or your Docker Compose setup. So that's another way of handling security for your external API. And finally, if you are actually particular about handling auth from the client, you can forward client headers to webhook. So if your action endpoint is also reliant on client headers, like some form of authorization header, you can click on this forward client headers to webhook, and Hasura will be able to forward those headers to your webhook, and you can pass it on your custom endpoint and basically do an error response or a success response depending on that. So this is for actions. Remote schemas has a very similar approach where you send in some form of a secret or an authorization header. Typically, it's recommended to use an environment variable. So I'm using an example of Contentful here, where I'm forwarding headers from the client, and I'm also adding an authorization token, which lets me access the Contentful API that I have, the Contentful space that I have with this para token. So this is technically the shared secret, which which will let me access this endpoint, right? So this is applicable for actions, remote schemas, and also for events. You can technically forward any kind of headers, which you can check in your custom code for manual verification, right? So that will prevent direct access to any of your HTTP endpoints if you're hosting it in a different place and if you're publicly exposing it. So secret sharing is a neat way. Um, and going back to actions, let's say I have this action. You can also define permissions for this. Currently, you can define uh, a permission which will let you access this action, which will let you perform this action query. But going forward, we'll also have granular permissions for the fields that you have for both actions and remote schemas. Right now, we don't have permissions for remote schemas. It's a work in progress. So going forward, you will be able to access permissions for field levels, right? So that's for both even for remote schemas and actions. So in all three custom logic use cases, you can have a common shared secret to prevent access, to prevent direct access to your API. So that's a recommended practice if you're not able to host it on the same cluster. And the next thing, yeah, I'm going to go back to comments again. Um, yeah, so Boris says more precise limits for the same role based on the data, different fields for the same role based on data, different fields for the same role based on the data. Maybe I didn't understand the question correctly. Different fields for the same role, right? I think um, I think if you have a requirement based on data, um, you will be typically using different roles. I'm not very sure about the use case that you are talking about, but typically, if that's the use case, you will probably have multiple roles, and on your client, what you can do is you can actually specify which role uh, that you want to be authorized as. So you can specify Hasura role manually on the client when you're making a request, and Hasura will check if it's part of the allowed roles list, and you can actually make a query depending on that, and the appropriate permissions will be applied, right? So that's about um, permissions, and we just covered security for external APIs, how to manage your external API. Now coming back to configuration. Um, so we looked at adding admin secret and the JWT configuration or a webhook configuration and so on. There is also another browser specific feature that you would want to enable in production, which is the cars domains. So let's say you are running this project and using it only for a web application. Um, uh, Here, you typically would want to restrict access to one particular domain to access this. So, for example, if your application is running on https myexample.com, you would want to restrict um, to only this domain to access your GraphQL endpoint from your browser client. So any JavaScript code that needs to be executed from your browser, any HTTP request calls can be made only from this particular domain uh, to your server, right? So, and you can also like do wildcard star dot my example so that any subdomains are also allowed, right? So this is another CORS configuration to specifically say that please allow requests only from these particular domains, right? So CORS is another configuration that you should be able to configure before going to production, and I recommend doing that if you're accessing it from a limited set of domains. Of course, if your API is a public facing SaaS API, you wouldn't be able to restrict the domains. You should be able to allow any domain to access it from anywhere, right? So that will be a different use case. But in a typical private project, public facing API, you can actually set the configuration to allow only the allowed domains that you want the browser to communicate, right? So that's one configuration to look at. Um, and I have another configuration that we can show. This is about timeouts. Um, so, for example, if you're making a pretty lengthy query, the one that I showed, probably this is not a very huge query, but let's say this probably takes a lot of time to execute on the database layer. You can set a timeout at the Postgres layer to say return a timeout if it's taking more than a few milliseconds, right? So there's something called a statement timeout in Postgres, which lets you access a configuration. So I'm just going to say statement timeout. Integer where in your Postgres configuration, you can specify the number of milliseconds that after which you can abort the execution of this of any Postgres query, any SQL statement. So this is a configuration of the Postgres layer, has nothing to do with Hasura, but just wanted to let you know that there is a timeout at the database layer that you can configure, and that would be go to secure an API if in case uh, somebody is making a malicious, a pretty lengthy query, right? And apart from that, there is a connection timeout that we have with PG connection. So there is definitely a flag. There is a connection timeout. I'm just going to search for timeout. So there is a PG timeout uh, environment variable which lets you close the connection before it crosses a particular time threshold. So you can configure this for a lower number if required. Typically, this is for the initialization of Hasura with the database. Um, so that's there for you. Um, then on the timeout thing, you can also configure timeout for your custom logic code. Again, going back to remote schemas and events, you have something called a server timeout. So this is your external API. So this is in this use case, this is Contentful GraphQL API. I have but the default configuration is 60 seconds. So you can configure this to a lower number to say that if the query is taking more than 10 seconds, please give me a timeout response from the server. So that's one kind of a timeout setting that you can configure. So if a particular query is taking more than a few seconds, typically it's something is down somewhere, and you'll probably have to debug in a better scenario, right? So this is applicable on both remote schemas and event triggers. You have timeout over here as well, and you also have retries. So if it's timing out, and then you have a retry interval to retry the query again, to basically schedule the event again, right? So this is for events. So you have timeouts at the database layer, and you have timeouts at the HTTP layer as well, right? So that's about timeouts. Um, Optionally, if you're so I have a couple of optional security stuff that you can do with Hasura. If you're hosting Hasura yourself, you can disable console using the disable console environment variable, um, and you can also disable APIs. So you can say enable APIs, and then just select GraphQL. So what this will let you do is, this will let you only access the GraphQL endpoint and not allow the admin endpoints like the metadata, the config, and the pgdump APIs, which are typically exposed for your internal stuff. In a production environment, you probably don't need all of these, so you can configure the enable APIs to just expose GraphQL, and disable any other production stuff like metadata and config, which is not required on a live server. So that's typically what you would want to do um, to protect your GraphQL server. Um, so right now, what is missing is permissions for remote schemas. So once you have permissions for remote schemas, you can do granular role-based access control for remote schemas, and that would close the loop of setting up authorization layer end to end. And I think um, that's mostly what I wanted to share today about securing APIs with GraphQL. Most of these approaches is just not limited to Hasura. You can apply this approach with any GraphQL server in general, not just Hasura or Hasura Cloud. Um, the concepts of rate limiting or role based access control is pretty relevant everywhere. um, the ease of use with which you can configure the access control system with Hasura makes it easy for you to use Hasura. The UI is pretty flexible to configure a row-based check, and you can use very complex Boolean condition as well, right? So the expressiveness of your permission system, which is declarative, is pretty cool, and that saves a lot of time in writing your own auth system. You have libraries like GraphQL Shield, which does this if you're writing your own GraphQL server. But there's significant amount of code that you need to write to replicate the functionality that something like this can give you, right? Um, that's mostly what I wanted to share as part of today's live stream. Um, I'm just going to look at the comments before we wrap up. Um, Ritesh says, "Hey, it's awesome. Keep it up. Thanks, Ritesh. Glad to see you using Hasura. Hope this stream was useful for you to secure and go production." Um, right. So I think we are mostly done with the comments as well. Um, I wanted to just share the link to the blog post that we have. It was published today. You can find it over here on the link below. And if you have any questions, you can post it on the blog post as well. I'll be able to answer them asynchronously. You can try out all of this uh, rate limiting stuff on Hasura Cloud free tier as well. Um, you have all the pro features ready. I'll definitely post it on chat as well. 1 second. Got it. Just picking the link here. Let's put it on chat. There you go. Right. So yeah, that's mostly it for today. So next week we have a live stream on schedule triggers, which will talk about how to replicate cron jobs through Hasura APIs. And we'll be building an exciting app. We'll be probably building like a calendar scheduling app, which would cover different use cases. So I'm excited for next week already to showcase a demo of building a calendar app with a proper authorization system and and replicating cron jobs with Hasura, right? So yeah, that's mostly it from my side. Thanks for tuning in today. Hope you have a good time. Looking forward to it. Thrashing code, yes. Thank you, everyone. Thanks for joining in. See you next time. Thanks.